So we'll now have a look at the rendering side of things in Deep Exploration. And for this part of the demonstration we're going to use a subassembly of this transmission so we can really see some detail in the output, and that subassembly is going to be this one here. You can see on the screen just this shaft with the spring at the bottom, gears on the side with the bearing. Now photorealistic renderings are becoming more and more important in the design environment. They can be used by designers and engineers to visualize a product in its natural environment. They can also be used by marketing departments for advertisements, for websites, and so on. One of the main advantages, I guess, of using these is that you don't have to pay for an expensive prototype or photo shoot, and you can use that CAD data which is already available to you. So this is the subassembly that we're going to be working on. And one of the first things we need to do is to add some sort of material and colour to this model. Now by default the model will come in with the colours just pulled through from the CAD model, and you can see they're listed in our scene tree, materials 1 to 6, and they just reference the default colours from the CAD model, as I say. Now Deep Exploration comes with an extensive library of very realistic materials, and we can flick through those materials here. You can see we've got different metals, different colours, different paints, all the way down to stone and concrete, and different materials as well. Now if I want to add a material, then I simply drag and drop it, as you saw just then. We don't have to mess around doing anything else. We just simply drag and drop that onto the component we want that material to be added to. Now materials are really quite a complex subject, and really a subject in their own, but to give you a brief overview of the materials, then you can see here that carbon fibre which I've added to the shaft has been added to my materials list in my scene tree. We can look at the properties here. We can see that this is a HDR material, that stands for high dynamic range, and we can see the type of material it deals with. We could specify like a high gloss paint or a matte finish there. Colour, different maps, so we can define different images, different JPEGs. We see the one there for the carbon fibre. If we want to specify a 3D texture is embedded into this component, then we can specify a bump map. We've also got what is being reflected in that material as well. So I'm just going to change the scale of that carbon fibre from 10 to 6, so we can just see that a little bit more clearly in our rendering. And what we need to do is go through here and pick various different materials for our different components. So for this spring, then we can add a brass material. Okay, so now we've got all our materials added, and we can orientate this round into a view that we're happy with. Now there are several different renderers within Deep Exploration. They deal with the rendering of the viewport and the rendering of the screen. Depending what graphics card you have, and the specification of that graphics card sort of depend on which renderer you use. But for these high resolution and photorealistic images that we want to create, then we want to use the high dynamic range real-time driver. High dynamic range is basically a set of techniques for the computer to accurately calculate light definitions, and it's this light definition that gives the images its realistic and photographic quality. With the HDR render mode comes the concept of environment maps. And environment maps are very high resolution 360-degree images of a certain environment, and Deep Exploration comes with a library of these environment maps and allows you to place your models into these environments for a more realistic image. So for example, we could place this assembly into a lighting studio as it is at the moment, or into something a bit more true to life. So we have this outback scene here, and you can see the reflection there in our sort of chrome shaft, and we can really get those high quality images that are required here. Again, another environment map, another standard environment map is this one of a grass scene or a hotel lawn. We can orientate these round and put it exactly how we want it. So for this particular rendering, then what we'll do is use one of the studio setups. So once you've got an environment that you're happy with and a set of materials that you're happy with, and your model's orientated around correctly, so you've got one more thing to do basically before you render this image, and that is to map to the UV. What that means is we want to map these materials, and you can see it just went through the process there. We want to map those materials to these 3D models. The process of mapping takes that 3D model and unwraps it into a 2D state, so it can more accurately calculate the exact light definition on those surfaces. So you can see here how that's been mapped to 2D, and those light calculations are much easier to generate. So we're going to render this image. We'll put it on a relatively low setting for this, so it renders a bit quicker. You can see here we've got a lot of advanced settings, and we'll set this rendering. So once this has rendered, then we'll see the real quality of this renderer. One of the things that's quite difficult with rendering is certainly the metals and the glass. And you can see from this image what a realistic render that we come out with, and this is on quite a low quality setting. Now, if you don't want to use one of those environment maps, you can use any 2D image as a background as well. So this is quite a clever aspect of this system. You can take the 3D lighting environment from this studio, but we can apply a 2D image as a background. I'll simply drag and drop this 2D image, and we can select it, we can scale it and move it around so that we get the exact view that we want. And just move this into position, and just orientate our model around, make sure it all fits in our output size. And again, we can then just hit the render button, and we'll see this image created. And there we go, that's that image pretty much done. Again, you can see the bit of grain on the shadow there, but overall an impressive result on a bit of a low quality setting. So I've got some images here which I've previously rendered. This is on more of a higher setting, and you can really see, if we zoom into certain areas, then we get an amazing realistic image. And you can imagine the money that you could save through not having to build certain prototypes and pay for photo shoots. We can just use that CAD data and render these amazingly good quality images. There's some other images here. They're playing this engine assembly, and they've all been done using Deep Exploration. So that's an overview of the rendering capabilities of Deep